Hello, everyone. Welcome again to Pharmaceutical Calculations with Dr. Dave. This lesson is going to be on alcohol concentrations and how we describe alcohol when it's being used in pharmaceutical preparations and products. So, now from chemistry, most of you are probably aware of what alcohol terminology meant, and usually meant something that had that OH group, an alcoholic group on it. But for pharmacy and for pharmacy compounding, and what we're going to do for pharmacy calculations, the word alcohol, when you see it used without any other designation, it's referring to 95% volume and volume of ethanol and water. So it's ethanol and water mixture. It's not 100% pure ethanol. We're talking about 95% pure ethanol. So it's ethanol and water. And that's based on a reference standard, which is called the USP, which is United States Pharmacopoeia, that states what conventional US pre-grade alcohol is. So it's 95%. It's pure ethanol. So keeping that in mind, whenever you see the term alcohol used in a formula just by itself, it's referring to alcohol 95%, the USP 95% grade. Some people will also use the word ethyl alcohol or absolute alcohol. That's referring to ethanol in the product. So any of those will be similar use. So ethanol, ethyl alcohol, or absolute alcohol. So if you see a product, even products over the counter, that you'll see they'll list alcohol, it'll say alcohol 20%, sometimes it'll say 20% by volume. But if it says alcohol 20%, that means that it's got 20% volume and volume of alcohol in the product. That is alcohol, the actual pure alcohol. All right? Doesn't mean that it has 20% of the 95%, if that makes sense. So there's a difference between when you see a product for compounded preparation or it's listing that you need to use alcohol, it says that you need to use the 95% one. Once it's listed on the label, it's the actual concentration of ethanol or ethyl alcohol that you're using. So let's do an example to help clarify what I mean. If you look at this compounded preparation that's in front of you, you'll see it's going to say you mix castor oil with something called acacia, and you have alcohol, cherry syrup, and purified water. So castor oil is an oil, and you're going to mix it with water. It won't mix well, so you have to use acacia, which will help to mix the oil and water. The cherry syrup is their flavoring, and the alcohol is there as a preservative. And it says that you need to use 15 mLs of alcohol. Notice it's the word alcohol. It's by itself. No other designation, and it tells you an amount of mLs to use. This would mean that you are using 15 mLs of the 95% USP alcohol, right? That's 95% volume and volume. So that's the alcohol you'll grab off the counter. And you will mix 40 mLs castor oil. You'll put some acacia, which is a powder. You'll have alcohol 15 mLs. You'll have cherry syrup, and then you'll put the final volume, QSAD with QS to the volume of 100 mL. So there's 15 mLs of alcohol USP in that 100 mLs. The question is, well, what concentration of alcohol, pure alcohol, is going to be on the label? Do not say that there is 15 mLs of pure alcohol in 100 mLs of the product, right? Because this is not 15 mLs of pure alcohol. This is 15 mLs of the 95% alcohol, right? The 95% ethanol. So in order to say what the label will list on it, you would say that you've got, excuse me, 95 mLs of ethanol, right? In every 100 mLs of this USP that you have. You are only using 15 mLs of it. So if you've got 95 mLs of pure ethanol, right, out of the 100 mLs, but you're only using 15, you've got 14.25 mLs of pure ethanol. That's how much ethanol is in this 15 mLs. This 15 mLs has 14.25 mLs of ethanol, the alcohol in it. Now you would take that and you divide that out. So 14.25 mLs of ethanol is in 100 mLs, right? And then you find your percent by that, right? So it's 14.25 divided by 100, and you're going to times it by 100, you get your percent, and you get the same thing. So 14.25%. That's what will be listed on the label, not 15%, right? So hopefully that makes sense to you. When you just see alcohol listed as an ingredient to add, you're adding a 95% pure alcohol. When you're listing it on the product wants to know what's the pure amount of ethanol in the product, not the type of solution you added. They want to know what the final is in the product. All right. There are times when you will see alcohol used to a specific concentration. So this says alcohol 15%. That doesn't mean you're going to use 15% alcohol. That doesn't mean you're going to be diluting down alcohol. This means that the final concentration is supposed to be 15% in this 60 mLs that you make. Notice the difference between alcohol 15%. It lists an amount of concentration. Here, it just lists 15 mLs of alcohol. If there's nothing after the word alcohol, you're talking about USP. If it lists the concentration that you want, this is the concentration in the final amount. Right? So in this case, you would see, right, that you've got 15 mLs in every 60 mLs of that compound. Okay, so let me clarify again. This is telling us that the final concentration of this is going to be 15%. But the amount that we have to make 60 ml. So let's talk about how we would make this. So let me ask this. Let me draw a picture as usual. You got 60 mLs. I want this to be 15% alcohol, right? 15% ethanol I want in this liquid right here. Right? How do I do that? How much ethanol do I need to have? 15. 15% means that I need 15 mLs of ethanol for every 100 mLs that I make. I'm only making 60 mLs. So if I needed 15 mLs of pure ethanol every time I made 100 mLs of a product, but I'm only going to make 60, I need 9 mLs of pure ethanol. I'm using the word pure ethanol to utilize alcohol because that's what I'm going to put in the formula, right? Or sorry, that's what this concentration is telling us, the amount of pure ethanol. Now the problem is when I go and make this, right, I'm not going to pull 100% pure alcohol right off the shelf. I'm going to be pulling 95% alcohol off the shelf in a bottle. And I need to add how much of this 95% USP grade do I need to get 9 mLs of pure ethanol? All right? What do I mean by that? For the USP, right, grade alcohol, every 100 mLs of that USP, right, contains 95 mLs of pure ethanol. If I want 9 mLs of pure ethanol, right, how much of that USP 95% do I need? So every 100 mLs is going to be 95% pure alcohol, ethanol. If I only want 9, that's it. So 9.47 approximately mLs, right? So I need a little bit more than 9 because I'm only using 95%. So don't get confused by the two terminologies here. When you're just using alcohol, you're using the product that you're dispensing, or sorry, the product you're using to make your preparation is going to be 95%. And then how do you list it on the final product is that you're looking for the amount of pure ethanol in the product. Here, we're saying that we want the product to be listed with 15% ethanol. How do I make it? Well, I'm not going to take 100% pure alcohol. I'm going to be taking 95%. How much that 95% do I need in order to get a 15% solution out of 60 mLs? They do make a 200 proof alcohol, but for compounding, mostly we're going to be using the 95%. So if it doesn't specify anything, it's USP 95%. That's something you should know. Alcohol, USP 95%. All right. Another thing that you will see in commerce is that the percentage of alcohol can be expressed in different ways for alcohol, right? We did it by the percent volume and volume, right? The amount of ethyl alcohol per mLs, right? You can also do something which is called spirit proof and also proof strength. A proof spirit is a 50% volume of alcohol and water, so ethanol and water. If you were above that proof strength, right, then you were considered above proof or above 50%. You were less than, it was considered less than that. And that was the way in which they used to to express the concentrations of alcohol based on that proof spirit, 50-50. Now we do something called a proof strength. And it's an expression that's made by taking that proof spirit, right, as being 100% proof. So we call that proof. So 100% proof would be 50% ethanol and water. So if you're going to take a drink, if you're going to take a shot of something and it says on the label that it's 50 proof, right, your alcohol, that means that 50% of that liquid that you're drinking is ethanol. The rest of it is a mixture of water and other things. If that says it's 100% proof, rather. So if your label says it's 100 proof alcohol, that means 50% of that alcohol is ethanol, and the rest of it is water and an extra. So look at examples of what I mean. So the proof strength is always twice as great as the volume and volume. Very straightforward. If something says that it's 200 proof, you divide that in half, you know that it would be 100% volume and volume of alcohol. This is 100% pure alcohol, ethanol, nothing else, absolute ethanol. Right? If some bottle says it's 100 proof alcohol, that means that it's a 50% weight, right? 100% proof, 100 proof, right, is 50%. If somebody says it's 50% proof, it's half of that, or 25% volume. You can go the back way. If you see a bottle that says it's 25%, right, volume of alcohol, multiplying it by 2 will give you the proof strength, which is 50. So let's do an example quickly here. If I have something that says the proof strength of a 35% alcohol aqueous solution, what is the proof strength? Well, 35% is the concentration in volume. If I take 35% and I multiply that times 2, right, I get my proof strength of 70. So this is 70 proof. If something says it's 95% alcohol, like our USP, 95% volume, multiply that by 2, I get my proof strength, 190 proof. I can go the other way. It says, what is the percent strength if I have a 120 proof? So if I have 120 proof alcohol, if I divide this by 2, I'm going to get a 60, which is 60% volume and volume. So that's the difference between proof strength and volume concentrations of alcohol, going back and forth. Right? Proof strength is double the concentration. Remember those questions that we had when we're looking at mixtures, diluting, and we're looking at liquids. 2 of them, let's look at this example. It says, how would you prepare 200 mLs of a 38% volume alcohol using 85% volume alcohol and purified water? Well, we can do our good old C1V1, C2V2. We have a concentration, boop. We have a volume, boop. We have another concentration, boop. And we're looking for how much of this do we need? We're looking for an ml, right, as well. So we have our C1V1, C2V2. Other ways to solve it, if we wanted to do the RC1V1, C2V2, our concentration of 1 is 38%. Our volume says 200 mLs. Our concentration 2 says 85%. And our volume, we don't know. We don't know how many mLs it is. What is the question even asking us? The question is asking us here, let me draw my little container here. Let me draw a little bit lower. It says, how would you prepare 200 mLs? So this is my little container, 200 mLs. And I want this to be a 38% volume of alcohol. How would I do that using 85% and water? So I have now a little bottle here. This is 85% alcohol, right? How much of this do I need to put into here? And then I'm going to QS to water up to the 200 mark. All right. This question is asking me, well, how much of this 85% do I need to put in here? That's why I set up my C1V1, C2V2. This tells me that the amount of drug, or the amount of alcohol here, right, in this bottom part, is going to be the same when I dilute it up to the 200. So if I take 38, I times it by 200, and then I and then I divide that by my 85, I get 89.41 mLs. What did I say, 49, or 89, sorry, 89.41. 89.41 approximately mLs. That means that this is how much 85% I'm going to put. I'm going to put 89.41 mLs down here. And then I'm going to QS with water up to the top. And that's how I solve that question. All right. So that is the information on alcohol in particular when we're looking at how to describe its concentration, how to describe its proof, and again, how we can do our C1V1, C2V2 to make alcoholic concentrations of different amounts. All right. As always, this pharmaceutical calculation is your most important class because it's the only one that counts.